Hi everyone, Dan Gutter from Insane Forensics. Welcome back to Tech Talk Tuesday, where every week we try to give something to help your threat hunting and security program. And today what we're going to dive into is actually a 3-for-1 around commonly used ports and protocols. So this covers T1071, T0869, and T0885 of the MITRE ATT&CK Matrix, both on the enterprise and ICS matrix. So let's dive into it. So we'll start with T0885. This is part of the ICS matrix called commonly used ports. And under this tactic, what it is, adversaries may use commonly used ports to bypass firewalls, blend in. They may use the protocol assigned with the port or not. And so what this tactic covers is basically the fact that, hey, in a lot of plants, between Purdue model zones, if you're in the OT space, between firewalls, in both IT and OT, oftentimes attackers will use ports that they know the firewall isn't blocking, even in places they know where there are firewalls, right? So like a lot of places, port 80, right? A lot of places, whatever's being used for remote administration, whether it be SSH, Telnet, another protocol. And in this case, right, this attack, so a lot does fall into this bucket. But in this case, right, it's just like, hey, attackers are going to be smart enough, again, to realize there's a hole through this network. I'm going to jump through the hole that's probably not being looked at. Where this is also smart, right, is people are just like, oh, hey, we have to open this port for this application. And they don't always look at what's going through that, right? And so attackers will also use that to say, hey, maybe they don't have the technology. Maybe they're not actually looking at alerts coming off of this. And so we're going to use commonly used ports. Again, this is part of the ICS matrix. So when we look at examples, going back to 2008 timeframes, Stuxnet C2 servers over port 80, Ukraine 2015 using port 443 for C2. So again, like, right, 7 years later, you're still using, HTTP, HTTPS ports to go over that. What's interesting with Triton, right, is the use of TriStation's UDP port 1502. In this case, right, the malware actually was sending bogus TriStation commands, both for the C2 and for the exploitation side. But again, what falls in the bucket of this technique is really any use of those protocols. Later, we'll talk about also how to detect, how to defend, ideas for that. But for today, for T0885, not just for today, actually, we'll talk on those defenses a little later. On T0885, it's really just using a port that was kind of expected to be used in the environment. So that covers the port side. Now we're going to jump into the protocol side, application layer. Both attack and enterprise matrix have equivalent ones that are somewhat the same on this, right? So we look at the enterprise matrix for T1071. Again, adversaries may use an OSI application layer protocol to avoid detection, again, blend in with existing traffic. Oftentimes, right, these are embedded into the actual protocol traffic itself. When we look at T0869, it's a similar deal, right? They're going to use common application layer protocols, and they actually call out HTTP. They throw in an industrial protocol, OPC. And so for those not aware, OPC DA is just DCOM. It's just the industrial name for RPC DCOM that's used in older stuff. OPC UA switched to an XML format a lot of times that goes over HTTP or over HTTPS. RDP, Telnet, DNP3, Modbus, right? So again, we have this on the OT side, on the industrial control system side. We have the IT protocols. Then we bring in and say, hey, they may use one of these expected major application layer industrial protocols like DNP3 and Modbus. And again, it's, as they say in there, it's for disguising. They may be seen on their ports or on non-standard ports. It's important to note here that in a lot of plants too, you can actually change the port that something spoke over. So just because it's on a non-standard port doesn't mean it's necessarily bad. It might just be a reality of the plants that you're at. Some industrial plants do security by obscurity, where they're like, hey, we'll just move this protocol to this other port and they'll never find it, or it'll take them a little longer to find it. And so in some cases, we've actually been places to where they've used that for the defense side, right? And again, it's for C2, it's for infecting devices, a lot of uses. When we look at uses of these two techniques, we see very similar things, right? So we look at T1071, again, on the enterprise side. You look at APT28's Drevorev, right? They were using WebRTC for C2. There's a really good Cybercom, I think, and NSA dropped a lot out. U.S. government dropped a lot out on this. Definitely check out that report. That has, why I like Drevorev is it's actually a very interesting use of WebRTC. What's cool with that WebRTC, though, is there's actually Wireshark dissectors for it already. And so you can actually get really close to dissecting it. They use some obfuscation, some encoding and other stuff to make it a little harder to find. But you can actually find this pretty straight out. WannaCry, right? We look at it, MS17010, Eternal Blue. We have SMB-based exploitation in C2. This is why WannaCry was so effective, right? Using an application layer protocol that oftentimes has to go between different parts of industrial networks, between different parts of other networks. Dooku, what's interesting on here, right? This is kind of the cousin, believed to be the cousin of Stuxnet. And in the enterprise matrix, they actually call out Dooku and say, hey, it's custom C2 over commonly used ports and protocols. Lucifer, another one, Stratum for cryptojacking and mining, another protocol, Telnet. We have IRC for Siloscape and Team TNT. And so, the possibilities are endless on here. And you use a tool like steganography, which, storage-based channels you can hide in different fields, just like we saw with WannaCry and with Drevorev, right? The opportunities really are endless for hiding in these protocols. And again, this goes for that same trust relationship of these are generally allowed through the firewall, right? A lot of places don't look at them again. When we move to the T0869 to the industrial side, right, we have Black Energy using HTTP post requests. We have InController using, for the Omron PLCs with HTTP, HTTPS, Oil Rig, REvil, again, using HTTP, HTTPS, right? So, that is not an industrial protocol, but it is used on all of these PLCs in all of these areas by a major group. I mean, Oil Rig is a big APT group. APT28 that we saw before is big APT groups, right? So this is something both the sophisticated and non-sophisticated groups are using. So Stuxnet, again, there was some really sophisticated S7com data block communication that was going on in the C2 of that. And we'll probably deep dive Stuxnet sometime later. Triton, using the Tri-Station protocol for C2, right? Notably, I mean, when we look into this, right, attackers have used both IT and OT application layer protocols. So this isn't, a lot of people are like IT, OT, very different. In this case, right, it's the same technique. We have two numbers for it, but really our examples really do bridge. We have OT examples on the IT side. We have a lot of IT possible stuff on the OT side. So it's important to demystify and say, hey, this really does apply to both sides. So how do we defend against this, right? There is the challenge to where as you scale, as you have more data coming through, it is hard to see use of commonly used ports and protocols, right? First thing, context matters, right? At the high level, you can certainly deal with kind of the net flow or the Zeek conlog level. You can do, sophisticated statistical analysis. When does this communicate? How often? Can I predict when this is going to happen? Is there a normal amount of data that's set? Just using, again, up to the TCP, UDP kind of packet layer without going into context on this. Your challenge is here, depending on the protocol and what's considered normal, you're likely not going to generate high quality detections. It's certainly possible depending on how you do clustering or you do other things in here, but it's going to be challenging, right? You need to really, as we get down to the next phase, understand the context at the deeper port and protocol level, right? And these are questions like, hey, what types of protocols are going over a given port? And then understanding how does my IDS or IPS actually stand up to identifying those protocols? So you use something like Wireshark, right? And Wireshark you can either bound a protocol to a given port, or you can do what's called a heuristic function to where you, in the dissector, write a function that basically says, hey, look for these certain things, return true. If Wireshark gets a true back, then it says, hey, it's this protocol. There's obviously danger because, a malicious or poorly written protocol could actually hijack the flow from another one in there. Or, in a lot of cases, IDSs might not actually identify the protocol over the given port, right? We see this too in even tools like Suricata, right? For certain protocols, you actually have to extend Suricata to be able to understand a given protocol. Obviously, in Suricata, you always could do a byte match if you wanted to do that, but in a lot of cases too with IDSs, you want to understand like, hey, how well can I actually identify protocols going over ports based on the limitations of the IDS, right? Context too, you can even get down to what types of devices are using a given controller. This could be down to the device itself. You could do this from subnet. Hey, what does HR really need to do to, my server subnet, right? Can I kind of baseline or get a behavior for HR between this, right? So what types of devices are using that protocol? Because again, if you see, like for example, HR, if you see it out of your HR subnet into another subnet or HR cluster of boxes, you see something suspicious saying, hey, maybe an attack group actually did pop one of those boxes in HR, and now they're using the standard ports and protocols to actually pivot out of it, right? And so again, understanding the context of your network is key. What protocol characteristics are normal, right? We look at HTTPS a lot earlier, but sometimes attackers don't actually set those TLS or SSL certificates to have in the right fields. Hey, the name field, the organization identifier, the other parts of those certificates that are attached with that, right? So getting down into there and saying, hey, this is normal. And again, this is something you can add to that statistical baselining to improve it. Industrial protocols, there's a lot we can do here, right? But getting down, like the next layer would be, hey, what industrial functions are actually being used between these assets, right? What an engineering workstation uses and what a human machine interface uses can be very, very different, right? One is oftentimes writing firmware, writing other things to where the other might be just pulling data. It might be writing certain values certain places, right? But really understanding like, hey, where are functions used? When are they used? And can I build some pattern to see, am I in a Ukraine 2015, 2016 type scenario for the power grid type attack, right? Am I in a crisis scenario to where, a safety system starts getting really weird functions that doesn't normally come off that type of box, right? Those are the kind of triggers to say, hey, while this is a common protocol, I can now see a very weird contextual use that can help me say, hey, this is a standard protocol, but this is certainly not typical behavior I should see. SSH and Telnet, right? What the best thing here is, again, seeing what accounts are being used where. What accounts, like back to the HR scenario, should you see an administrator SSH or Telnet down into another subnet off of that box from a HR endpoint to where there's generally not an administrator on that box, right? Understanding how SSH and Telnet is used in the environment, even if it's perfectly normal, right? And finally, what are the capabilities of my tools looking at the given port or protocol? We've talked about this a bit, but to the point of automated versus manual analysis, it's really important to understand, again, what your tool actually looks at, what it's good at looking at, what it's not good at looking at, what it expects you then to also do. So there's tools out there that trigger out and say, hey, this is bad. Here's a PCAP now. You get to go through it, right? And so understanding the limitations of how deep it can contextually go is key. We put a picture of a haul truck here on the left. Haul trucks are great examples. So we were working on a certain vendor's haul truck, and what's cool with it is they actually use part of the haul truck like web interface is written in Python, which was weird because we're like, wait, we're seeing like all of this like Python based web server metadata coming off of this haul truck, right? So as we were digging into the HTTP of that, it's like, okay, wait, it's actually normal to see Python going to a haul truck associated with some of the web interfaces. And by the way, some of the web interfaces tie to certain parts of the haul truck, right? And it's like, okay, let's see what's normal going to this given component on this server on this haul truck. And by the way, why haul trucks are cool, so in parts of the world, they're running these completely autonomous, right? And so the software is key because it's basically a robot driving. It's a giant robot driving that can pancake a car without a user inside of it. It's really has this traffic going to it. And so when you talk about building like a traffic baseline for a haul truck, it's a great example because there's a whole lot of web interfaces on these. These are super expensive trucks. They have like 750 gallons of gas. They're like $3.5 million each. It's a crazy kind of use case for when we talk about commonly used ports and protocols again. You look at an asset like this and you certainly can actually build behavior around it. So again, hopefully this was helpful. We wanted to take these three MITRE ATT&CK techniques, or commonly used ports and protocols, which on their own are hard. And especially if you're like, well, Dan, how do I actually deal with these? We wanted to give some ideas for building better baselines, for understanding what your capabilities are with these, to hopefully help you deal with these better, right? Because as we saw, there definitely are major attack groups that are using this protocol or using these two techniques. I'll say what's on the MITRE page is very non-complete compared to the number of use cases out there. And so, as you're going through threat intel reports, as you're going through community reports, as you're going through stuff you have, really think when you think on these three on, okay, well, how do I, one, would my detection actually find this now? Two, do I need to update my detection engineering to maybe bring this in without bringing in too many false positives? And three, then how do I scale this, right? So thanks for tuning in this week. We hope to see you back next week.